In this session, we will solve problems on closures. We have a relation over here R where the attributes of the relation R are A, B and C, and given this set of FDs where A functionally determines B and B determines C. Now, let F be the total set of FDs which hold on this table. So I can say that F equals to F1 plus F2, where F1 is the set of visible FDs and F2 is the set of invisible FDs. So now which is the set of visible FDs? We have A determines B and B gives you C. What about the invisible? Is there any FD over here which still holds but is invisible over here? If we apply the transitivity rule, then it says that A determines B and B determines C, that means A determines C. So we have an FDE, that is A determines C. So basically this closure set of attributes is required for normalization process. So what do you mean by normalization? Normalization is nothing but process of trying to eliminate the redundant data from the database. So before going with normalization, it is very important to have the entire set of FDs. So we compute it using closure set of attributes. So what is closure set of attributes? It is the set of those attributes that can be searched based on a given attribute. We will solve some problems on closure set of attributes. Now over here I am taking the same examples once again, and I am trying to find out the closure on A, closure on B and closure on C. I consider the FD alpha determines beta. Okay. So what is the closure on A? The closure on A is A. So it is basically trivial. So when you have A, you have A with you. Next, now you check if this particular attribute appears anywhere on the left hand side of the FDs. So basically I am applying this particular rule, that is alpha determines beta. So I have A on the left hand side, so basically alpha determines beta. So if I have A, I can say I have B. So the closure on A is A, B. Now you check from this set of attributes if any of the attribute is occurring or combination of attribute is occurring on the left hand side of the FDs. So we have B which is appearing over here. So if I consider this as alpha and this as beta, so if I have alpha, I have beta. So if I have B, I have C. That means I have C. So now the closure on A is ABC. So what is the closure on B now? So the closure on B is B itself, and if you have B, you have C. So the closure on B is BC. What about the closure on C? The closure on C is C itself. So basically if you have A, you have all the other attributes. So the closure on A is ABC. Next example, calculate the closure on, for this example, calculate the closure on AC plus. So what is the closure on AC? So if I have AC, I have AC. Now I apply the same formula, alpha determines beta, functional dependency, and I check if AC or A or C appears anywhere on the left hand side. So I get to see over here A determines B and A appears on the left hand side. So I can say now that the closure on AC is A, C. Next, if any of these attributes occur on the remaining FDs, Yes, BC appears over here and we have BC over here. So BC gives you DE. So A, C, B, D and E. Now, what about the last FD? We have A, we have E, but we do not have G. So basically now the closure on AC is A, B, C, D and E. So if you have AC, you will be able to compute this attributes A, B, C, D and E. Next example. For a given relation R where the attributes are A, B, C, D, E, given this FDs, find the closure on B. So we use the same formula, alpha determines beta. Closure on B is B itself. B occurs anywhere in the relation, anywhere in the set of FDs, yes. B determines D, so we have B, D. Anywhere else? So the closure on B is B, D. Next, find the closure on AB. So alpha determines beta. Closure on AB is A, B, and the first FD says AB determines C, so we have A, B, C. The second FD says BC determines AD, so we already have BC over here, so BC determines AD, A is already present, so we have A, B, C, D. The third FD, D determines E, so we have D over here, so now we have A, B, C, D, E. And the last FD, CF. Anywhere CF occurs, CF does not occur anywhere. We have C but we don't have F. So the closure on AB is A, B, C, D and E. Next, for this relation, we'll again find out the closure on AB. So the relation R where the attributes are A, B, C, D, E, F, G and H. So you have to find out the closure on AB. So AB gives you AB. Now, first step, first FD, A determines BC. We have A over here. So we can say AB gives you ABC. Next. So anything more that we can find out? CD. So we have only C over here. E not appearing. D is also not appearing. ABH, we have A, B, H is not there. DH, both the attributes are not there. So the closure on AB is A, B and C.